everybody, welcome back to CIS 17A. Today we are going to be covering lesson number 18. This is going to be our second to last lesson of the semester. So today we are going to be starting off on page 869 and work our way through to page 889, and then there's a few pages in here we're going to skip that have some questions in the book that we're not going to answer, but for the lab I am going to have you answer another set of questions that starts on page 877. So let's go ahead and jump on over to the book and start working our way through here. What is inheritance? Inheritance is when you create a new class that is based on an existing class. Another way to put it is that the new class inherits all of the member variables and functions, as it mentions here, not the constructor or destructor of the class that it is based on. All right, the idea is generalization versus specialization. And we see this all the time in the real world. So we have terms that describe things in general ways, and then we have other things that are more specific versions of that general thing. So the book gives an example of an insect. An insect is a very general thing. There are millions of different kinds of insects. Don't quote me on that number. So what are some different types of insects? We got grasshoppers, we got bees. So a grasshopper is a specific version of an insect. A bumblebee is a specific version of an insect as well. However, they of course are very different. So while they are different, they are also going to have some general characteristics that they share in common. And when it gets to things that are specialized, like the ability of a bee to sting or the ability of a grasshopper to jump, those are specific things to that specialized version of an insect. All right, so again, thinking of it this way, insect is the general thing. All insects have certain things that are in common to them, which make them considered insects. But then we have specialized versions of insects that have their own specific abilities. And as the book mentions, this is what they call in C++ a is-a relationship. Now recall back with our last lesson that we talked about aggregation, and we said in aggregation that a class can have as one of its attributes another class. So that's an example of a has-a relationship, not an is-a has-a relationship. So for example, in the linked list, a linked list is a class and a node is a class. And a linked list has a node. So that's a has-is relationship. Now, inheritance is always an is-a relationship, and we can see down here what it means by that. So in this, these are going to be what would be considered the what are called base classes or the general classes. We'll just stick with the term general class for now. So this is the general, and here is the specialization. So a poodle is a dog. A car is a specific example of a vehicle. We could also have trucks or trains or airplanes. A tree is a plant, but we could also have a bush is a plant. A cactus is a plant. A mushroom is a plant. All right, actually, they're not. They're a fungus. Never mind. Go take a biology class. Shapes. A rectangle is a shape. A circle is a shape. A parallelepiped is a shape. A football player is an athlete, but so is a baseball player, and so is a swimmer, right? So these are all examples of specializations. These are all examples of general things, and that's the idea behind a is-a relationship using inheritance. Okay, so this is saying more of the same thing. And let's go ahead and move down here and take a look at an example. And unfortunately, the examples in the book are very long-winded. I'm going to try to get through them as best I can in a quick way so that you guys don't get bored or lost as I'm trying to explain it, but it's not going to be easy. The book's examples are kind of convoluted. All right, in any case, all right, so here, this is going to be our generalization. And they use the term base class. Oh, they did it right here. So now I'm just going to stop using the word generalization and specialization and call it what they actually are. So you're going to have a base class, which represents the abstract or generalized thing, and then you're going to have the derived class, which represents the more specialized thing. So I'm not going to use the terms general and specialized anymore. So we have a base class and a derived class. So the derived class will have all of, or inherit all of the stuff from the base class. All right, so let's see an example here. So in the book, it's going to use an example of a graded activity. So think of a classroom. You're in the classroom. Your teacher's going to give you lots of different types of work to do. So, for example, you may take an exam in a class. You may have to write an essay in a class. You might have to take a true or false quiz in a class. So those are all three different derived classes of the same base class, which is a graded activity. So a graded activity as a private member variable is going to have a score, and that's it. All right. What score did you get for that particular activity? And notice that they're representing this numerically as a double. All right, but we also know that a score, a numeric score, can also be represented using an A, a B, a C, a D, or an F. All right, as your grade as well. Okay, so what do we got going on here? So we're going to have a default constructor. Remember, a default constructor is a constructor that isn't passed any arguments, which just sets the score to 0. We're going to have another constructor, which we pass the score to, so we can initialize it when we declare an instance of a graded class, a graded activity. All right, so all that does is set the score to whatever the user passed to the constructor when they declared the instance of it. All right, finally, they're going to have a set function, which we can use to modify the score, and a get function, which we can use to retrieve the score. And notice that everything here is being done inline, right? They're not splitting this up into the header file and the .cpp file. And the book's doing that for the same reason that you're going to see me do it when I go to demonstrate some code. It's just a matter of time to just keep things simple, right? And we don't have to split everything up for now. But if you were doing this on your own, you would definitely want to split things up to make it cleaner. All right. So let's move on. So there was only one thing in here that was not declared inline. Am I missing something? Why are we doing this get letter grade? Okay, there we go. All right, yeah, this is the only member function in this example that does not have inline because it's too long. So this get letter grade actually is split out into a .cpp file. All right, and that's what we're looking at here. So the only thing that would be contained here is the definition for the get letter grade member function. All right, so let's go through this real quick. So it's going to return a char, so we're converting the numeric grade into a letter grade. And then the first thing we've got to say is which class this belongs to. It belongs to the graded activity class. We've seen this notation by now. And this is the name of the function get letter grade that we saw right here, get letter grade. So what does this do? We don't pass it anything. All it does is look at the private score member variable and figure out what letter grade it corresponds to. So, and then the other thing is that you don't really need to do this. You could just return the character right here. You don't need to do it, but whatever. So they declare this temporary variable for the char, and then if the score is greater than 89, then we set that to A. If it's not, then we check to see if it's greater than 79. And if it is, then that means they got a B, so on and so forth. And then if it wasn't any of these cases, the default is that they must have got an F. All right, so last but not least, we just return whatever that variable got initialized to. Okay, so that's the get letter grade member function. Okay. So here we're going to go ahead and just drive that member, that class using some simple code. So let's make a placeholder for the person to enter the score. So we're going to ask them for the score. Here we're going to declare an instance of a graded activity, and we're going to name it test. Then down here we're going to call the set score function, and we're going to pass it whatever the user entered, and that's going to set the score. And then last but not least, we're going to print out the letter version of that numeric grade that the person entered. So let's see a couple runs of that. It said, what did the person get? The user entered 89, and then the program called the get letter grade member function, which converted that into a B. They ran it again, 75 corresponds to a C. All right, so hopefully that's not too confusing. So that's our base class. We haven't done anything with inheritance. In fact, we haven't even done anything new. All right, so that's what I mean. Like, these examples are really long, and nothing new happened in anything that I just explained there. You guys have all done, hopefully, stuff like that before, declaring a class and defining the member functions and then testing it out. All right, so nothing new. All right, here's where we get to the new stuff. So here we're going to use inheritance. All right, the way that we indicate to C++ that we are inheriting something in a class is right here. So all that work just to show you that little simple snippet of code right there. All right, so what we do when we have a derived class is we put the name of the derived class like we normally would after the keyword class. But then we add that colon followed by the word public followed by the name of the base class. So here we're going to create an example of a class that is a final exam. So in addition to a score, which the graded activity has, a final exam also has a number of questions that were on the exam, the number of points that each question is worth, and then finally the number of questions that the person missed when they took the exam. We're going to have a default constructor, sets everything to 0, and then we're going to have another constructor where something a little funky happens. All right, in the other constructor, we're actually requiring that the user enter the number of questions that were on the test and the number of questions that were missed. Notice that we're not asking them for the score and we're not asking them for how many points each question was worth, because we can derive all of that information based on the number of questions and the number of questions that they missed, assuming that the test was worth 100 points, which is what they do later on. Okay, now here's where they do something kind of odd, and I'm just going to disclaim this right now. This is not normally how you do this. The author is just doing this to show you guys a simple example, which actually ends up being more complex than it needs to be, ironically, but just to show you a simple example of an inherited class. So it's calling a function called set. Now notice that up here in the graded activity class definition, there is no member function called set. There is one called set score, but there's no function called set. That member function set is actually defined here in the final exam class. All right, so that's kind of funky because they're actually calling this function set before it's even been defined, and you can do that. That's allowed if it's all within the class like we see it here. All right. So notice that this is not the definition, this is just the prototype, and that we're going to have to wait a little bit and look down in the source file for the final exam to see how this is actually working. Okay, but we know that it's passed an int and an int, just like we see it getting past the questions and the missed from here down to here, from here down to here. So it's just getting passed from here right along down into this function called a set. Okay. All right, these are just simple get functions that return the private member variables. So num questions is the one here, and then points each is here. It's just returning that value. I almost don't even need to put those there. It just makes the example more complicated, but whatever. All right, same thing with get this get num missed. It's just returning that private member variable. Okay, let's move on to the set, the infamous set function that I pointed out earlier. Okay, so for the set function, same thing in a typical definition. It's not returning anything. We're saying that this is a member of the final exam class, and the function is called set. We passed it 2 ints. This is where, unfortunately, it gets a little complicated, and unfortunately, none of the complexity in this contributes to actually understanding what an inherited class is. All right, so just hang with the logic, and even if you don't understand the logic, it's okay. In fact, you know what? I'm going to skip over the logic for now and just jump right here to the very end. This is what's important about the set function. It's calling a function called set score, and it's passing it this value called numeric score from this function. All right. Again, don't worry about any of this garbage right here for now. Okay. So where is set score? What is that from? Come on, computer. So where is? You can tell it's 11 o'clock at night when I'm recording this, so I'm a little grumpy. All right. So where is the set score function from? The set score function is from the graded exam class, right? So what we're doing is, because this is a public member function of the base class, we can call it in the class where we inherited from, all right? So going way back down here again. So we're going to call this member function of the base class. Again, this is not, just to show you one more time, this is not anywhere here in, so we're in final exam, and nowhere in here do we have a function called, what they call it, set score, right? So there is no function. There's get points, there's set, but there's no set score, All right, so inside of our call to set, we call set score and we pass it this value. All right, so let's walk through this garbage here real quick. All right, so a final exam has a number of questions and a number that you missed, right? And we're just going to initialize those with the values that were passed here to the set function. And where were those passed? They were passed here. So a lot of passing around of data. So the user provides these numbers when they initialize the instance of it. We just simply pass them off to the set function. Then finally, did I skip past it? I did. So then, and then finally, those get copied from here over into here. Whew, that is a lot of passing data around. And again, we'll see later on that this is usually not even the way you do it. But hey, I'm just trying to explain the book to you guys. All right, so that data initially gets. Now let me just move on. All right, so hopefully you understand what these represent, right? Okay, so points each, simply put, is 100 divided by the total number of questions, right? There's 2 questions, each question is worth 50 points, right? Moving on down to here, the score. We can calculate the score by subtracting off the number of points that they missed, and that is equal to how many points each question is worth times how many questions they missed. All right, so from the total, we just subtract that off, and that gives us the numeric score that we pass finally using set score from the base class here. All right, so that's going to set, and so going way back, whatever value is here, that's going to get stored. Again, sorry for all the scrolling, you guys. That's going to get assigned to this variable here. All right, so I'm sure half of you right now, your heads are spinning as much as these pages are spinning in me having to go back and forth with everything. Okay, so that's how that class works. All right. Really, the thing to focus on is, again, the simple thing. By putting the colon, the word public, and the name of the base class, we're using inheritance. So this all right here is inheritance for the final exam. All right, all it's explaining here is where things are from. So set score, get score, and get letter grade, those are all inherited from the graded activity class, and then everything else, the private members that we see here, the public members that we see here, those are all defined, or we saw they were all defined in the derived class definition. Okay. All right. Yeah. We didn't, and then again, I don't know why they even provide these because they don't show them. Actually, I think they use them in the example when they actually run the program later on. But up to this point, we just saw them using the set score that was inherited to initialize score in the base class. All right, moving along. Okay, so here we're going to actually finally drive this thing and test it out. All right, so we're going to create an instance of a final exam right here. Okay, and we are going to pass it questions and missed, which were grabbed from the user. So how many questions were there? How many questions were they missed? We're going to name this instance of the final exam test, and we're going to pass it that data that we collected from the user, and then we're simply going to spit that data right back out. And in this case, we're going to spit out the score. So based on the number of questions and the number they missed, we use the logic that I just walked through up there, and then we're calling get score. And again, note that get score is not defined in the derived class. That's from the base class. Also, we're going to get the letter equivalent of it. And again, that's not in the derived class. We inherited that from the base class. When we run it, it could look something like this. There was 20 questions. They missed 3. That means that the questions were 5 points each, and that the person got an exam score of 85, which corresponds to a B. Wow, that's a lot of stuff to walk through there. All right, but I got through it pretty quick, 18 minutes. That's not too bad. All right, so there you go. So let's go down here, and then before I get into that, yeah, they're just saying here what I just said a second ago, that those were from the base class. Okay, let's do this real quick. So note that you can't go the opposite direction. It is definitely not the case that a base class inherits anything from the derived class. So here all they're doing is they're saying this is a bad class. And here we're going to say x is equal to get val. And where is get val? Get val was was defined in the derived class. All right. So you can't do that. You can't, whereas we can in the derived class call public functions from the base class, we can't go the other way around. We can't, in the base class, use public stuff from the derived class. It doesn't work like that. That's like the equivalent of saying, well, I don't want to say, I'm just going to leave it at that, right? Okay, next, here's page 877. These are a bunch of questions that I want you guys to answer for the lab. So you're going to answer all that stuff here. And then as before, you're just going to write that up into a Word document and submit that to Canvas. Okay, protected class members. And I promise I am going to go through and give you guys some examples of code here in just a minute. I just want to get through all the bulk of the text before I do that. Okay, protected members. Well, I don't know if I said this explicitly, but in fact, let's go ahead and do that now. Why not? All right. So let's make a class, and we're going to call this shape. Okay, it's going to have, like every class, it's going to have private stuff and it's going to have public stuff. So a shape. Shape could be like a circle, a square, whatever. But what's something that could be common amongst all those things? Well, what we could say is that all shapes have a color. So we're going to use a char to represent the color of the shape. Okay, so then down here, let's go ahead and make a constructor. And then we're going to say that the constructor requires that the user provide a char when they declare an instance of a shape. And I'm going to use inline, again, just to save time, and say that the color, it gets initialized to whatever the user provided when they declared the instance of my shape. Okay? All right. That's it. All right. Next, let's inherit from shape. So let's make an instance of something more specific. Let's make a class called square. So a square is a shape. And now let's use our fancy new notation. We are going to inherit, and I said we use the word public, and I'll explain more about the word public in just a little bit. And we are going to say that shape is the base class. So there's my base class, there's my derived class. All right. Now, I don't know if I explicitly said this, but it probably said it at some point in the book. Anything that is private in the base class will remain private in the derived class. So just to show you that, let's go ahead and make this have its own private data and its own public member functions. Okay. Okay. So what does a square have? A square has a length. So let's go ahead and give it a length. And then it's going to inherit that it also has a color from the shape class. All right. So down here, let's go ahead and give it a constructor. And then for now, let's go ahead. I don't want to write all that crazy set function stuff that they did. I guess I have to, huh? All right. Let's go ahead and do the same, initialize this the same way that the book did. All right, so we're going to require that the user provide the length, and they provide what color the square is. And then we're going to inline over here, and we're going to say that the length is equal to L. And then here's where we're going to see the issue. Now, I said that we inherit everything, but that's not totally true. When we use the word public here, and again, I'll explain more about why in just a second, it means that anything that's private here remains private. That nobody else outside of the shape class and outside of the shape member functions can directly access the color variable. So down here, I can't just say color is equal to C like this. As you can see, the compiler automatically flags that as an error. All right. So you should definitely know that when we say public, what we're saying is that anything that is public in the base class is also public down here. So if I had done this, if I had made this public instead, now all of a sudden I actually could do that like this. Okay. Why is that a problem? Int char. Did I misspell it? No. It's because I misspelled it. S-Q-A-U-R. So S-Q-U-A square. There we go. All right. So now what's going on? Now it's saying no default constructor exists. Oh, that's right. See, that's a problem. It's okay. Yeah, it's right. I'm getting an error message that says no default constructor exists. So I guess it's just worth mentioning that when you create a derived class, it has to call the constructor for the derived class, but it also needs to call the constructor for the base class. And because I said here that I'm requiring it to be passed a variable C, I'm not doing that down here. I'm not calling the constructor and passing anything. So what it's assuming is that I have a default constructor up here. So if I go ahead and throw a default constructor in here like this, which does nothing, now it makes the error go away. So what's going to happen is it's going to call the default constructor, which does nothing, and then it's going to initialize the color to C. And again, the only reason that I'm able to directly access it is because I switched it to public, right? All right, now this is bad. We never want to do this. Never want to do this. Because it's the same idea as the get and not the get. It's the same idea as the set functions in class. The set function should do some type of error checking to make sure that when the user tries to call that function and change the private data, it should do some type of error checking that makes sure that it's valid, right? Like, so for example, with the graded exam or the graded activity class, if we try to pass a score that is less than 0 or greater than 100, maybe we flag that as invalid, right? And we have to do something about it. But anyways, so let's change this back to private, okay? And we can see that the point I was trying to make is just that we can't directly access, even though we inherited it, and that we do have a color variable for each instance of a square, we can't directly modify it like we're trying to do here. So that's why the book went through and made that set function. So let's go ahead and do set color. And we pass it a char. And then make this inline. And then this is going to, and then we're also going to have to declare a function here, set color. And actually I'm going to just call this one set square color. Okay, just distinguish the two. And set color is going to get passed to char. And then set the color. Okay, there we go. Why are you not happy? Color missing int. Yeah, duh. This needs a return type. So there. Okay. All right. So now that we have all that garbage that we added, what we can do here is instead of trying to directly access it, we can use the function that we just created right here. All right. So we can say this. All right. Actually, we do need a semicolon there. Okay, wow, that's a long way around, right? Okay, so, oh, and then down here, we're still not done. We need to call set color and pass it C. All right, and then semicolon. Okay, so there's a lot going on here, right? And now if you're confused and you're kind of like, wow, that's a lot of work just to like, you know, to initialize the variable color. You're right, it is a lot of work, but fortunately we're going to see in just a couple minutes here that there's a much more elegant way to do all this that doesn't require as much overhead. All right, so just so we can go ahead and see how everything is working, let's see, public. Let's go ahead and have a get char, and then we'll call get color. Okay, which is not passed anything, and all it does is return the color. And then down here, finally, we'll make this return the length. So it's going to return int. This is going to be get length. Okay. All right, so let's try this out. So let's make an instance of a square called S. We will pass it two things. We need to pass it the length and the color. So for the length, we'll make it a length 4. And then for the color, we're just using a character. So R means that it's a red square. Okay. And down here, let's go ahead and just see that it got the data. So we're going to say S dot get color. Actually, we did the length first, so why don't we do the length first here too? S dot get length. And then S dot get color. All right, there we go. All right, so we're just kind of driving this class to see if it works. So let's go to run it. Oh, yeah, it's going to get it from the constructor. I was thinking I didn't put a CN statement. It's okay. Ah, there's builder. Okay, I know. Oh yeah, I put return L. We're not returning L, we're returning the length. Okay, let's try that again. So not a very fancy program in terms of the output. So all that work just to do this, right? So we declare an instance of a square, we name it S, and we initialized it with the value of 4 and R, and then down here we used our get functions. We used get length, and that printed out the value of 4, and then we called get color, and that returned R. So what is the things that we need to focus on here? Okay, let's focus on a couple things. First off, that the color that we passed to it R and the function get color were not members of square, right? Get color is not in here. We got get length, but we don't have get color. It inherited that from the base class shape here, get color. So even though this is a square, not a shape, it still had a member function called get color. That's inheritance, right? Even though it doesn't have a color, it just has a length, we still were able to pass it a color and store that color in that variable or that class that we named S. All right, that's inheritance. Okay. All right, now it may seem like this is an awful lot of work just to you know, store two variables, a length and a color, but it doesn't make sense if you look at small programs like this. When you start to do large-scale object-oriented programming, this is absolutely crucial to understand how to do, because it's the only way you can avoid from your code from just becoming like this tangled mess of all these different things that you have to jump all over to try to understand. By encapsulating all the data like this, it makes it much, much easier to work with large-scale programs. The other thing is that by using inheritance is it allows you to divide up the code. I might, in a large-scale team, I might have one person that's responsible for all the code for the shape class, and then another person that's responsible for coding all the stuff that has to do with the square, right? So I'll give you an example of like a game engine. In a game engine, you'll have a base class called game object, and a game object can be an animated character. A game object can be a static character that doesn't move around. A game object could be a sound bit. A game object can be a particle effect, right? So in that class, what's happening is you're assigning everybody to work on different things. So one person's responsible for all the animated characters. One person's responsible for all the non-animated stuff. One person's responsible for the audio, and they all inherit from the same thing. So and that's again going back to the idea of private variables. You wouldn't want somebody from, let's say for example, somebody's working on audio to mess with stuff that every single game object in the game inherits, because then you could have one person on the team break something for everybody else. And that's something called the principle of least privilege. It's the same idea with the set functions. We don't want set functions to be able to pass bad stuff to a base class, or not to a base class, but to a class in general. We always want to validate things that come in so that it can't cause other stuff to break somewhere else, right? So think of that. Think of it that way. Think of one person working on all this stuff and another person working on all this stuff, and it makes more sense why you have object-oriented programming. All right, it's worth the overhead. Okay, let's go back to the book here. All right, so, okay, a graded activity. I forgot where I left off. Protected members. All right, so again, okay, with a protected member now, let's go back to here. I think I already showed you guys that by making it public, we could access it. So let's go ahead and, instead of making this private, let's go ahead and make this protected instead and see how that changes things. So if I made that protected instead, what I could do is, I'm still going to need the default constructor, is it's like when I made it public before. When you make something protected, it makes it so that any derived classes can directly modify that variable. So for example, I could go do something like this. I could say, instead of calling the set color function, I could actually just get rid of the set color function altogether. And I could just do something like this. I could just say that the color is equal to C, like that. All right. Color, and then down here. In fact, don't even need to do this. I could just put this and completely get rid of this function. Okay. All right. So again, the reason that I can do this is because I changed it from private to protected. All right. So let's go ahead and just run it. So now it's also worth noting behind the scenes that but in between here and here, it's calling the default constructor. So if I got rid of this, I would get a compiler right there. Okay, see the red line? So again, you always have to have the constructor in the derived class. You always have to call the base class constructor. So if you don't have a default constructor, it's going to require you to provide one. All right, but again, notice I'm directly accessing color. And if I run my program, I should get the exact same output. So there you go. Right. I passed in 4 and R, and when I call get length and get color, I still get 4 and R. Okay, now it's worth noting, so that's, again, I'll just restate it. So anything that's protected, okay, but I guess I should point this out. So what's the difference on here? So here, if I go s dot color is equal to R, I'm trying to access that private variable from outside of the instance of the class. So that's not allowing me to do that. And that would be true if it was protected or if it was private, okay? All right, so I could make this public, actually. Now watch what happens. It got rid of the little squiggly line. This is terrible. You would never want to do this. You would never want from main something to be able to go into and modify something that's an internal mechanism of the class. This is like the equivalent of letting you, from the driver's seat of your car, go in and change the timing of your spark plugs, right? Or go in and change, like, from the driver's seat, you can like push a button and change the number of antifreeze in your car, right? Or you push a button and change the oil level of your car from the driver's seat and start dumping the oil out, right? You would never want to allow that kind of access just from outside of the class, right? So you would never want to do that. So what we're doing is with protected is we're just kind of rolling it back one layer. I can't spell tonight. Protected. All right, so what we're doing is we're rolling it back. We're saying, hey, you can't do this. We're not that extreme. But we're assuming that, hey, if you're here and you're in the class and you're derived from this class, that, okay, we'll relax our our guard and say, okay, we'll let you change it. But I'm going to go ahead and just say, again, this is very strongly discouraged, because even though you're rolling it back one layer of protection, you're still allowing the base class to directly modify the contents of the, did I say base class? You're still allowing the derived class to directly modify the contents of the base class, and that's never a good thing, all right? So this is almost always what you see in programming. All right, so let's fix this over here. So I think we're almost done. And in the interest of time, let me see here. Final exam, does this do? I'm going to let you guys read through this because we're already getting well into things here. Oh God, yes, this is a just score example is just like, all right, so basically what they do is in the set function that you saw a second ago, they at the very last minute call this a new function called adjust score, which, so I know I'm kind of bouncing around here. So we're back to talking about the final exam inherited class of graded activity. So adjust score, what it does is it looks at the score that the person got, and it rounds up if the score that they got, if the decimal part of the score that they got was greater than or equal to 0.5. So for example, if the score that they got comes out to be like 67.7, it rounds it up to 68. But if it was 67.2, it just leaves it alone. All right, so it's like just I don't know. It's just an example. There's no real firm logic behind it. Okay, but I'm gonna let you guys read through that. It's just, and really, this hellaciously long example boils down to one thing: that they're going to make it protected, which means that the inherited class can directly modify the score. And down here, when we call set, we call this new function adjust score, which directly modifies score. All that huge example just to show you that. Okay, so that's a lot of, I mean, read through it. It's good to read through it and understand it. It's going to help you understand inheritance. There's a lot of logic in here that has nothing to do really with inheritance, just to get to arrive at this. Like, hey, look, this is in the graded activity class. It's not in the final exam class, and we're directly modifying it. Isn't that neat? Yes, author, it's very neat. And then here we're going to go ahead and run an example of the code where we ask for the number of questions, how many did they miss, and then this is using that adjust function. As it points out here, the student would have gotten this score. They would have gotten 68.75, and then using that adjust function that they define up there, it rounds up to 69 instead. Okay? All right. Let's move on. All right, base class access. So I'm finally going to explain this a little bit more. And once again, this is one of these cases where people don't really use anything other than public. So just as in, okay, so let me just start by talking about member access versus base class access. So what you've been seeing in the class up to this point is member access specification. That's what we're putting here when we put private or public, or here when we put private or public in a class definition. So that, sorry, I'm getting lost in my thoughts in here. Okay, so that's member access specifiers, private versus public. Okay, member access specification. Base class specification is when you put public, private, or protected here when you're inheriting from a base class. Okay, all right, so for you guys, I'm not going to expect you to understand how private or protected base class access works. All I expect you to know is what I just got done explaining to you guys. So here when they say public base class access, they're referring to the word public here versus the word protected being here versus the word private. And then here they're just explaining what that means relative to the base class. What that means is that anything that is, and this is really just telling you what the example we just went through. When we use public, anything that is a private member of the base class is inaccessible. right? We cannot just go in and, like we see the error message here, it's private, and even though we're inheriting it, we can't directly modify it. Anything that is protected will become a protected member of the derived class. So that means that if I change this from private to protected, now I'll suddenly be able to access it because it's going to treat it like it's a protected member of its own class. All right, and then finally, anything that is public becomes a public member of the derived class. That's what we said way back at the beginning. So for example, this getColor function is public, which means that I can call getColor from here inside my square class. So just as a quick example, I'm going to go ahead. It doesn't make any sense. I'm just going to stick with explaining it to you guys, not trying to come up with an example. So again, using public, geez, using public base class access, it makes it so that all the public members of the derived class are also available to call. Okay. All right. Let's move on. Let's see. The base class access specification is left out of the declaration. The default access specification is private. Yeah, that's bad. You don't want to do that. So here, what they're doing is there's nothing was provided, no public, not right here, no public, no private. So the default then is it's going to treat it as private, and you don't want to do that. Okay, let me back up just a little bit and mention why at least these are so bad. And really, it's kind of summarized here in this picture. Over here, we have a base class that has private, protected, and public variables, and they don't put the full thing. They just say that it's got a private thing called X, a public protected thing called Y, and a public variable called Z. And how is that treated over here? Well, when you use private base access specification, so when you use private base access specification, this is what happens. Inside of the derived class, even if you set something to public, it will be treated as private in the derived class. That would mean that I can't, if I go back over to here and I make this private, am I calling? Yeah, I'm calling, oh, I didn't call getColor. Let's well, I'm thinking I can't come up with a pretty simple example. Let me just go back to the book and just explain. Again, I'm not going to ask any questions about this for a test. So even if you don't understand what I'm saying right now, it's okay. You don't need to know it anyway. All right, so, but again, this is the problem, is that when you use private base class access, it takes anything that's public and it makes it private, meaning that in the derived class, I couldn't call any, even if they were made public, I couldn't call any of the member functions from the base class. So like in the earlier example I gave, we used get color down here. We used get color for our square, and that allowed us to call this function from the base class. If I make this private, I'll get an error message now down here. Right? So this completely defeats the purpose of inheritance. The whole idea behind inheritance is that I can make one thing inherit all the public stuff of something else, so that I can use it down here when I actually go to create an instance of it. Right? So this right here is the reason that this is almost never private or protected. And the same thing is true here with this. Anything that is public becomes protected, and that's just as useless, right? So if I make this instead protected, again, now I can't use any of the public member functions from the class. So that's why I don't think I've ever seen anything other than public used in inheritance. So there you go. So now it got rid of that error message. Okay, we're almost done, I promise. Okay, so you don't need to answer these questions for it. And again, for a quiz or an exam, I just expect you to know this right here. All right. So let's move on. All right, constructors and destructors is the last topic. Okay, you should know that when you have a derived class, that the base class constructor is called first, and then the derived class constructor is called next. And for destructors, the order is reversed. The derived class's constructor is called first, and then the base class destructor is called next. Okay, and then they just give you a real quick example here. It couldn't be more simple. This is just saying, hey, look, I'm in the base class constructor. Hey, I'm in the base class destructor. Hey, look, I'm in the derived class constructor. I'm in the derived class destructor. And then here, all we do is declare an instance of it and then see what happens when we run it. So we're going to print out, we will now define a derived class object. The base class gets called first, derived class gets called second. We print out the program is now going to end, and then the derived class gets called, destructor gets called before the base class constructor. And that's all they're saying. That's all there is to know about that. Easy, simple, moving on. Okay, passing arguments to the base class constructor, and finally we arrive at the way that you should initialize the base class, and that's using arguments to the base class constructor. Okay, so I think I'm going to just go ahead and skip this example and go right to my code and give you guys a straightforward example. All right, so here has been the thorn in our side, right? How do we initialize private data inside of the base class? Well, the elegant way to do it is to call the constructor to the base class. And to do it, all you got to do is put a colon and then call the base class constructor and pass it whatever was passed to the constructor in the derived class, here, in this case, the color, C. And then we don't even need to deal with this now anymore. In fact, we don't need to deal with the fact that we didn't have a default constructor before. And bam, look at that. Look how much that cleans the code up. I know a lot of you are probably looking at that thinking, yeah, that looks so much more straightforward now, Mr. Fass. Really, at the end of the day, this is the way you almost always do it, right? So I'm not a big fan of default constructors. I more prefer the camp of require when somebody makes an instance of your class that they require that you require that they pass in the arguments like we saw here, right? Instead of just saying, let's go ahead and make S, and then later on we'll call set this, set that, and then we'll let the default constructor manage everything else by setting it to 0 or an empty string or whatever. All right, so there we go. So this is it. That is how you pass data to the base class using its base class constructor. So just so we can see that this still does the same thing, let's go ahead and run it again. And we see that we get, someday, hopefully, what's it doing? Ooh, it's taking a long time. All right, so we see we get the exact same thing that we've been looking at this whole time. So we declare an instance of a square called S, pass it for an R in the constructor, and now we are just being a little bit more elegant. We are calling the base class constructor to initialize it. That means that we don't need to deal with the color variable over here. We just need to initialize our stuff, so that's much more elegant. And then we let the constructor handle whatever else was passed to it, and then that's going to set the color to C. And again, there's no error checking going on like we normally would want to see, but hey, that's okay. So there you go. All right. Okay, and again, I think I'm just going to let you guys read through. Yeah, so the book, just to give you a little bit of a heads up and not just leave you totally on your own, they're going to create a class called Rectangle, and then they're going to inherit publicly from Rectangle and create a cube. So what is a cube? A cube is just a three-dimensional version of a rectangle. A rectangle has 2 dimensions. It has a length and a width, and a cube has, in addition to that, a height. So a cube is 3-dimensional, has a height, width, and a length. And then whereas a rectangle has an area, which they don't put a variable aside for that because of the whole idea of, I forget what they call it, like degraded data or something like that. They just have this get area function that you can call to get the area. But in this one, they're going to go ahead and explicitly have a volume for the cube. So remember, the volume is just the height, the width times the length of something. And here they're using the new syntax that I just showed you. So they're calling the rectangle default constructor here. So this is a default constructor where they just set everything to 0. height, volume is set to 0. They call the default constructor for rectangle, which sets its length and width to 0. And then they have another constructor down here, which is a little bit more fancy. Here in this constructor, the person provides all three things, the length, the width, and the height. And then here they're calling the constructor, and they're passing along W and LEN here. All right, so you just keep that in mind that whatever you put here, you can pass it along over here in this base class call. And then that leaves the height for us to set using this. And then here they're going to call get area. Again, this is the advantage of public inheritance, right? I'm sorry, public inheritance. Public base access of using the word public here is that we can do this. If that was private, we wouldn't be able to do that, right? So we're going to multiply the area times the height, and that gives us the volume. Okay. All right. Let's see here. They're just explaining the same thing that I just explained. And then what are we doing here? And then in here, they're just explaining that the first example of the cube was all done in line. So in the constructor here, let's go back up here. So in the constructor here, you calculated the volume here in line versus down here, where they're actually going to have the constructor definition do it here instead. So here we have the constructor 2 is just a prototype. It's not all done in line. And then down here there's the definition for the constructor where we set the height and the area, the volume. All right, last thing to mention and then we're done. So first off, the derived class constructor parameters can be provided here. So what we're saying is the values that may be used as base class constructor arguments. So it's saying what arguments can we pass here? Well, we can use the derived class parameters. So we can pass any of these things that were passed to it over here. We can use literal values. So I could pass in 5 and 6 or something like that. We can use global variables, but we know that if it's a global constant, that's good. We could do that if we wanted to. And then finally, expressions involving any of the things combined. So I could say W times 2 or length plus 5 or something like that. All right. So those are the things that you can pass as arguments to the function call to the constructor of the base class. All right, you guys. Now, that's the end of the lesson. All right. Oh, here, well, not technically. Here they're going to go ahead and just derive it once. So declare and ask for the width, the length, and the height. We're doing that here. Declare an instance of a cube, pass it those things that you just collected, and then print out stuff using the get width, get length, get height, get area, get volume. All right, so the thing to notice here is that get length and get width are being called from the base class. So again, even though it's a cube, we're calling the base class member functions, the public base class member functions. And then these are all functions. Well, this one's from the base class too. And then this one is from the derived class. All right, so just printing out a bunch of values based on what the user put. Okay, and then if the base class has no default constructor, then the derived class must have a constructor that calls one of the base class constructors. So what that's saying is that over here, what that's saying is if we don't have a default constructor, that we have to call one of the constructors from the base class in order to initialize it or to create a valid version of it, right? Okay, that's it, you guys. So I know that's a lot of stuff. I know that it's probably quite confusing for many of you right now. However, really just kind of boils down to a couple things. Using this notation along with the word public to derive from a base class, and using this notation right here to call the constructor from the base class and initialize it so that you can get all your data loaded up and ready to go. All right, and I know that's an hour-long talk just to summarize with those two things, but it really kind of comes down to those two things when you use inheritance. All right, so answer those questions that are on page 877 and upload those, and that's good to go for this. Our next lesson, we'll see how we can use inheritance to use a very powerful feature of the language called polymorphism, which is a way for dynamically calling different functions from the base class in a derived class. But again, don't worry what that means. We'll explain that in the whole lesson next time. All right, you guys, stay safe out there, stay healthy, and I'll talk to you guys again soon.